Again, my name is Jason Shepard, and what I do is I specialize in data center site selection and acquisition for corporate clients. We do not represent any landlords or any specific data center operator per se. It's 100% representing users and from a consulting standpoint and evaluating sites, locations, and data center trends. So I've got about 30 slides here, some of which are kind of the transitional slides. So I want to spend some time talking about with content with everybody. First thing first, again, just a couple touch points, just a couple slides about ourselves just to help illustrate hopefully the authority and perspective, and then jump right into trends and location considerations. We call our group here Mission Critical Solutions because, again, we're working with users, not only just data centers, but also from the standpoint of the telecom side, network operations center, e-fulfillment centers, and so forth, as well as our cloud customers. We really kind of feel that, when you're working with professionals from a consulting standpoint, that you really need to kind of work with the experts, not just someone who says that, gosh, we can help you with your data center needs, but they have no data center experience. It's really important to understand from our perspective, it's still a commercial real estate type of a service, an IT service, an execution history. Personally, I've done the work for about 20% of the Fortune 150 just since 2005 alone. Some of the illustrations where I've done data center deals really across the United States. And what I'm not illustrating here is all the work we've done with Canada as well. Mission critical only focus, my 18-year career working on data center facilities. And some of the proprietary tools that we have developed as far as mapping infrastructure of power lines and infrastructure across the United States that really assist our corporate clients in doing data center deals. That's enough about my background. So let's talk about trends. And the purpose of this call today, understanding that my unique perspective in doing the work for about 20% of the Fortune 150 is what are some of the challenges that we run into up front? And then also, what are the challenges that IT is dealing with? First and foremost, we look at data centers in really three categories. First, data center operators. They are the corporate users, Fortune 500 type companies who typically have their primary data center facility located at or near corporate headquarters campus where the CIO is. And then they may have a disaster recovery facility or a business continuity facility. According to Gartner's research, which is a little bit dated at this point, but it's just over 40% of companies have 3 or more data center facilities. Unlike an internet data center facility, the Facebooks, the Googles, the Microsofts of the world, who have those larger data center facilities predominantly housed with servers. So for example, what might work for Microsoft is not necessarily going to work for the corporate user, the smaller corporate user. I've had customers of mine out of the southeastern United States fixated on what some of the internet data center companies are doing up in inland Washington, for example. But I think you'll see here in our site selection considerations that that doesn't necessarily work for the traditional corporate user because it might be well outside of their acceptable latency distances. And then the third category is what we call 3POs. I call them 3POs, third-party operators. We have wholesale colocation as a baseline. They might turn around and lease that to a retail colocation provider, who might have a managed services provider as a client, who might have a cloud provider as a client, who might have Cresa, my firm, as a client. It's a stacking plan every step of the way. 3POs are chasing where the customers are, the density is. Internet data center facilities are typically chasing lower power costs and economic incentives. And that corporate users are really kind of tethered to their primary data center. So extremely risk-averse users here in the corporate user side. Let's talk about the evolution of technology. A little bit of data center humor here, but the old mainframe computers in the 1980s, low watts per square foot, to the rack-mounted data centers in the 1990s. The blade servers came out in 2001 before the market really kind of fell apart. And so as far as overall trend, if you look at the average life cycle of a data center facility maybe being 15 years, being that we're here in 2013 heading into 2014, if nobody was really building data centers between 2000 and 2005, we saw a small window of opportunity between 2006 and 2007. before the financial markets cratered. A lot of those new build projects got put on hold. So in my experience, you're dealing with a lot of corporate users who are dealing with antiquated facilities and trying to find out what really is that next step. As way background, I'm used to working 20 to 25 projects in some way, shape, or form I touch every year. In the year 2010, I saw about 40. In 2011, I saw 70. None of those projects in 2010 or 2011, or I said very few of those projects in 2010 and 2011 were closing because most corporate users really still hadn't really, virtualized their data center facilities, had a clear vision as far as what their needs were. And so there's a lot of, in my experience right now, there's a lot of pent-up demand out there for newer, more state-of-the-art type facilities as clients continue to consolidate their infrastructure by way of virtualization, but still needing new, more state-of-the-art facilities. So a tremendous amount of growth in the actual market. Cost of downtime. Now, this information is a little bit dated from 2011, where Emerson Research did their study of cost of downtime, where the average cost of downtime was about $5,600 a minute, called $336,000 an hour. I've seen other statistics saying $5,000 to $9,000 per minute. Some of the banking clients that I've worked with have significantly more cost per downtime, including loss of faith. Right? How do you put a dollar amount on those types of impacts? So, according to the DCUG Fall 2012 survey, now again, about a year old, this information, 69% of users prefer maintaining high availability versus reducing energy usage. Kind of an interesting statistic just to illustrate the dominance of maintaining high levels of reliability. Let's talk about, I know this slide kind of seems kind of weird, right? But if we think about this slide as being raised floor, most on the corporate real estate side, who brokers are in essence talking to, are dealing with corporate real estate, which is really supporting the below the actual raised floor, whereas IT is above the raised floor. The challenge is the IT teams and corporate real estate teams, they don't always communicate very effectively. In fact, here's an illustration of often the CIOs or their brokers are talking with the actual real estate departments who really have no relationship with the CIO whatsoever. Even the CFO to the CIO communication is often strained because they don't speak the same language. This is another illustration of that. So, for example, even in the IT world, the most important applications in the IT world are often referred to as your Tier 1 applications, and the least important applications are your Tier 4. Whereas on the flip side, on the other side of the barrier here is corporate real estate and redundancy as far as tier levels of data center. The most important redundant facilities are your Tier 4 facilities, and your least redundant facilities, often your server rooms and office suites, are often looked at as a Tier 1. So it's this big disconnect, even in the basic terminology when they're having conversations. A lot of the way that I've found is the best effective way to communicate and bridge the gap between corporate real estate teams is to use analogies and metaphors, which effectively for me is, for example, even leasing data center space. I've often compared it to leasing your car payment. So instead of thinking about like $500 a month for your Suburban, think about it as $500 a month for your V8 engine. Whether you're towing the boat to the lake or you're just driving to the office, you always have the right to that amount of power capacity. But in addition to that, you pay for your Chevron bill separately. Using these types of analogies really help bridge the gap between those departments and have them understanding the go-forward strategy. Again, this is another one for the corporate real estate teams who are often tasked with securing space. The cloud isn't really a mythical place. In essence, you're using somebody else's data center facility. Now, I don't want to get into CenturyNet's business of the cloud consulting here, but my only point about showing this slide is that there really is a confusion from the corporate real estate side relative to really what is cloud. Again, you're using somebody else's data center, whether it's an infrastructure as a service like an Amazon. The analogy I use there is who has an iPhone here? You're back up to the cloud. Well, you're using the an Amazon data center facility, whether that's in Salt Lake City or you're using an iTunes data center facility in North Carolina. Platform as a service, software as a service. One of the fundamental questions that I have, and I can pose back to Sentinel at the end, is what impact does distance have on software as a service? Is it effective if you are a customer in Atlanta to use a software as a service provider, their facility out of the Pacific Northwest? Are there latency restrictions? These are all questions that are important to pose whenever you're looking at any type of data center solution. This is one just consolidated chart of key data center statistics to know. One of my favorites right now is, just, again, an illustration of the difference between corporate real estate departments and IT departments, or the barrier between their communication. According to the Uptime Institute's 2013 Data Center Industry Survey, 80% of in companies, corporate real estate is paying the electricity bill for the IT team. And this is actually 3 years running. So it's just an illustration of that disconnect. Server virtualization and server consolidation still, is having an impact. Average KW per cabinet is 5.94. If you look at the average the average concentration of power densities, currently, according to the DCUG Spring 2013 survey, 37% of companies are between 2 to 4 kW per cabinet. But in 2 years, they're expecting to be at 4 to 8 kW per cabinet. The challenge is, unless you're securing a new facility or a third-party operator's facility to help you accommodate that need, how do you really change the engine in your airplane when you're driving it? Again, my recommendation, if the attendees on the call today are on the IT side, help your real estate team start to understand IT using simple little mathematical equations, such as if we've got 10 racks at 3 kW per cabinet, that equals 30 kilowatts. If I've got 20 cabinets at 10 kW per cabinet, we're going dense, that's 200 kW. For me, that translates into square footage on the previous page down below. So if you were to look at, for example, 250 kilowatts worth of power at 100 watts a foot is the same thing as saying 2,500 square feet of raised floor. Help your real estate counterparts translate that power into square footage. Some of the other key findings of the data center industry survey from the Uptime Institute this year is the perception of zombie servers, for example. Nearly half of survey respondents had noted that they have no scheduled auditing of unused machines inside their data center facility, and only 14% they had over 10 or more comatose machines. However, the industry survey illustrates that they believe it's closer to 20%. Again, a disconnect. And it's also another illustration here where the preference has mostly been for corporate users to want to go out and build their own data centers over the years. Well, now there's been a shift, and the onus is now on the corporate data center user, this first bullet point here, to demonstrate that there really is a need to build their own site versus offloading to a third-party operator. It's really good and valuable information. So again, at the end of the day, what the whole idea is, again, this is just an illustration of what we do, is that we work with our counterparts on the commercial real estate professionals, so we're working with the corporate real estate departments or directly with the CFO to help bridge the gap between the IT and real estate departments. We'll talk about site selection considerations here, and then we can open up for questions. So we look at, and this is, by the way, this comes from 18 years of experience working with end users, never representing landlords, always representing the end users looking for data center facilities. Site selection grid, which I'll share in a second, and there's typically the flow of site selection, natural hazard, utility consideration, the power cost, the reliability of the power, how much downtime could that lead to, by what grid or power grid are you on in the United States. One of the important considerations from site selection is not only the power cost, but also what is being used to generate that electricity, because every state has their different mandates for renewable electricity. Okay, what are your broadband considerations? And finally, TIA 942 there are certain guidelines that say that for a Tier 3 data center facility, you should not be within a mile of an airport. You should not be in a flight path. You're not to be within a flood zone and a half mile of a rail line or an interstate highway. Now, you don't throw the baby out with the bathwater. Everyone has their challenges. The whole idea is mitigating against risk as best that you can. So let's look at the overall. Again, I re-included the actual site selection for, the 3 types of data centers, because we're focused on here in this first chart is for enterprise data centers, EDCs. So this is my site selection grid that I've developed over the last 18 years of doing this. And by the way, this isn't out of a book. This comes from trial and error over all the different projects that we've worked on. National considerations, starting with risk, for the corporate users, EDCs, enterprise data centers. Risk mitigation first and foremost through utilities considerations, power cost, volatility, fuel mix, latency considerations, water, sewer, and climate. There's one of the major financial institutions that we represented, extremely large data center facility, and we were going to need 1 million gallons of water per day just to replenish what was being evaporated. Well, is it fair to say that we go out to a rural area town where the maximum well output for that entire town is 1 million gallons of water per day? No. So the whole idea is getting to areas that have more available redundant resources, but yet still being outside of the actual risk. If you pass that national test, you move on to regional considerations. If you pass that test, you move on to the site-specific considerations. Here's an example of the natural hazard map of the United States. Coastal California, the higher risk seismic zones, hurricane-prone areas. I always love this this picture down here because this is a picture of the Lieutenant Governor of Mississippi pulling themselves along the actual power lines during a flood. Again, just a rule of thumb relative to power cost. For your annual electricity cost, every 1 cent per kilowatt hour per megawatt. And a rule of thumb for megawatt is every 10,000 square feet of raised floor that you have at 100 watts a foot is 1 megawatt of power. So let's just think about it as 10,000 square feet, right? So if you have a 10,000 square foot data center at 100 watts a foot, every 1 cent per kilowatt hour at a 1.5 PUE here is going to equate to $131,000 a year in electricity bill. Now that's if you have your foot on the gas pedal the entire time, not attributing any discounted load factors. But that is in essence going to look like your cap, right? Again, before any type of taxes and so forth. Well, that said, if you're in the the south or the northeastern United States, where you might be 15, 16, 17 cents per kilowatt hour, well, multiply that 15 times your $130,000 per year, and by dropping down into the Virginias, for example, you can see how you can significantly drop your power cost. Now, again, when 80% of companies, corporate real estate, is paying the electricity bill for the IT team, you start to illustrate that, wow, this becomes like an epiphany for the CFO to say, well, gosh, wow, I can save that much money by having my data center facility in a lower power cost market. But remember, it's not just enough just to drop down into a low power cost market. You want to make sure you're looking at what is the long-term viability of that particular marketplace to provide me clean energy and stable energy. We're also limited for corporate users on where we can go because of things such as latency. So for example, Los Angeles, I'm in Southern California. Our primary data center market here from Southern California is often Phoenix. It's 11 milliseconds round trip latency versus Phoenix to New York is 63 milliseconds. If you have an outward latency cap of about 30 milliseconds round trip, a Phoenix-based data center facility is not necessarily going to come to Phoenix. For a smaller enterprise data center, they're often going to find a more regional hub. So again, often that first step is identifying what are your restrictions, and those are things that we look at as far as accomplishing through a data center needs analysis. And anyway, and so this kind of begs that question relative to a software as a service, for example. If that software as a service provider's facility is in Phoenix, Arizona, can it reasonably support the facility coming out of New York? Back to the data center types, what I want to look at now is the third-party operators from a colocation standpoint, because really kind of the growing market right now has really been on wholesale colocation. Retail colocation is how we've looked at the traditional form of colocation, going to a Savvis, going to an Equinix, etc., where you have your cage space or your individual cabinets, and then you're paying a cost per whip, right? The challenge for that in today's marketplace is you have a lot of universities, as an example. Universities might often have their certain professors who use their power consumption for certain periods during the month, but they don't use it for the rest of the month. Again, it's kind of like it's kind of using the car analogy to help your corporate real estate team really visualize this. That's the equivalent of me flying into an airport, going to Hertz, and they asking me if I'd like to prepay for my the gas in the gas tank. I say sure, so I pay my $70 per. I pay for all the gas in the gas tank. But I drive to a meeting 3 miles away and back and hardly use any gas. The same type of a thing in a retail co-location facility is if you're pre-committing to all of that power consumption, does it not make more sense to separately meter and only based upon the consumption that you're using? So it's more of a shift that we're seeing towards a wholesale co-location type of a model. Retail co-location really breaks down into 2 subgroups. It's either the carrier-provided co-location facilities, a la AT&T, Level 3, Verizon, Time Warner Telecom, et cetera, or you have your carrier-neutral facilities, the Savvises and Equinixes of the world, et cetera. Wholesale co-location has historically been those 500 kilowatt requirements and above, but we're now starting to see those wholesale co-location providers come down even into the 150 kW range. Not in every market, but which leads me really to my last slide, which is where are wholesale co-location hotbeds today? And we still, if I were to kind of compare this back to the late 1990s tech boom, where the deregulation of the 1996 Telecommunications Act, there was that race for space across the United States by CLECs. And the CLECs were really concentrating around Tier 1 markets, the New York Cities, the Chicago, San Franciscos, et cetera, where you have a lot of density. And then they were building out their data center facilities as to move up the value chain to corporate users. We're really just now starting to see the wholesale co-location providers who have since 2005, 2006, were really started to come to life. Wholesale co-location providers are really now expanding into those second-tier markets. We're really starting to see, for example, a new flood of activity going on up in Minneapolis as an example. So anyway, so the wholesale co-location model really is kind of the super growing force. It's, again, with the onus being on corporate real estate to really justify to their CFO building new themselves, it's really got to be a very large data center facility to make those economies of scale work. So co-location really is going very strong. So